Some past questions on circle theorems. Question number 1. Write down the angle ABC. ABC is that angle there, and give reasons for your answer. You need to know that the angle in a semicircle is right angle, the one that touches the outside there, that one there. So that is a right angle, and of course that'll all add up to 180 degrees. Next one. D, E and F are points on the circumference of a circle with centre O. Work out the angle DEF. So it's asking you for that angle there, and that is 65 degrees because the angle subtended at the centre of the circle, which is that one, is twice the angle subtended at the circumference. So that angle there is always half of that one, or that one is always double that one, depending which way you want to look at it. Question number 2. B, D and E are points on a circle, centre O, so B, D and E, there we go. Find the angle ABD. So that angle ABD is that angle there. We know that angle ABE is a right angle, so that's a right angle there. So what you do is do 90, take away 35, which gives you 55 degrees. Find the size of the angle DEB, Deb. So DEB is there, so you're after that one. First of all, you know that one is a right angle, because like we did in the previous question, question 1. So do 180, take away 90 at 35, and it gives you 55 as well. Yes, 55, there you go. Question number 3. The diagram shows a circle. O is the centre of the circle. A, B and C are points on the circumference. Whatever that. Work out the size of the angle AOD. AOD is that one there. First of all, you know that is a right angle in there. You know that's 36. So 90 out of 36, 126, and 180, take away 126, gives you 54. Work out the size of the angle ABC. ABC is that one. So all we need to do for this one is that angle there is half of that one, and I'll explain why in a moment. But first of all, you need to just half it, so that's why it's 27, and give a reason. This smaller angle is half of angle OAD, because the angle subtended at the centre of a circle is twice the angle subtended at the circumference. If you're ever unsure about that in exam paper, and it looks about half, just half it and have a guess, because usually one out of 2 times, that's what they're looking for. Question 4. A, B and C are points on the circumference of a circle. Centre O, points A and C. AC is the diameter. Look at that angle ABC. Again, that's a right angle. Should be getting used to that now. Give a reason for your answer. The angle in a semicircle is a right angle up there. That's not the diameter, I suppose. D, E and F are points on the circumference of a circle, as you can see here. Work out the size of the angle DEF. So that angle there. As we've discussed before, the angle subtended at the centre of the circle, which is this one, subtended at the centre of the circle, is twice the angle subtended at the circumference. So this angle here is half of that one, so that's why you half it, and it's 65. Question 5. And the diagram A, B, C and D are points in the circumference of a circle with a centre O. Work out the value of x. X there is 140 because, and we're getting used to this, the angle subtended at the centre of the circle is twice the angle subtended at the circumference. So that is always double that, which is why it's 140. Angle Y, question B, 1 is 110 because, and this is a circle theorem you've got to know, the opposite angles in a cyclic quadrilateral add up to 180. So what that means is that angle there and that angle there add up to 180 degrees. So that's why that one must be 110. Question 6. P, Q and T are points in the circumference of a circle. Obviously centre again is O. The line ATB is a tangent to the circle. So if it's a tangent, we know that and that must be right angles. Calculate the size of OTQ. So OTQ. So it's after that angle in there. Right, I'll try and explain this as best I can. Angle PQT, so PQT, so that one in there is 58 degrees, because it's an alternate segment to angle PTA, which is that one there. So they it's an alternate angle. Angle QPT is 61 degrees, so QPT, that is 61 degrees, because that's an isosceles triangle, and an isosceles triangle adds up to 180 degrees. That's how you work that out. Angle QTB, again, that's an alternate segment to the one we just worked out, so it's 61 as well. Angle OTB is a right angle as discussed, because it's a tangent to a radius. So that angle in there, which I'll just shade in to make it clear, that's what we're looking for. So you do 90, take away 61, which is this one here, of course, is 29. So it is 29 degrees. Question number 7. A, B, C, and D are points in the circumference of a circle. Find the angle ACD. So it's that one in there. It is 54 degrees, because an angle subtended by an arc in the same segment of a circle is equal. So that means they must be equal. So 54 degrees. Another circle theorem there to learn. And that's your questions on circle theorems.